Hi everyone, welcome to this video, and we'll be going over solving the transfer function of several building blocks. As you can see here, we'll be going over 4 of them, and we'll show how we can deal with different problems. So let's dive into the question number 1. So the question is essentially saying, find the open loop of the system, assume that there is no feedback. So essentially, the question is saying find a C over E when there is no feedback. Imagine that there won't be any H involved. So we will have only these components in the forward path. We'll have GC, GA, GM, and GP. And also there will be a D involved in this process. However, for the open loop, what we will need to do is just consider the input coming from the E and not through D. So essentially, this problem can be simplified as just considering the fact that we have E and that feeds GC, which feeds GA, which feeds GM, and this feeds GP. And here is C. So essentially, as simple as it sounds, C over E is simply multiplication of all of these transfer functions because they are cascading each other, and we can multiply them in order to get the final transfer function. So it's essentially going to be GC, GA, GM, and GP. So that's part 1 of the question. Part 2 is saying closed loop transfer function C over SP. So imagine that now we have all those closed loop system. We have H involved here as well, but still we don't have D as an external source. We will just consider the input to be SP or the set point. Now the transfer function can start, I would always recommend to start from the output. Now that we have C at the output, let's try to see that how this path is going to take a measurement from C and feed it to this error detection. It's essentially going to be multiplied by this H because in this return path, in this feedback, it's going to be exactly on the path. So essentially, whatever before H we had is going to be multiplied by that. And we need to remember that when we have a node that has an output of C, regardless of the number of outputs from that node, all of those are going to be C as well. So all of those outputs to the right and to the bottom are going to be C. And also the input of this H is going to be C as well. Output of this is going to be C times H, essentially, which in our case is going to be labeled as CM. Now, CH is going to be subtracted from SP through this error detector. This error detector is essentially saying that E is going to be SP minus CM. It's essentially multiplying this plus sign by this SP and also multiplying this negative sign by this CM and then sum them up, or essentially subtracting SP from some CM. So we have SP minus CM, and we can replace CM with CH because we typically don't want to use intermediate nodes. We would be interested in only the inputs, which is SP, or the outputs, which is C, or all of the individual building blocks that we have here. So we don't want to involve intermediate nodes as CM, and if there is any, we will be replacing them with either inputs or outputs or the building blocks that we have. Now that we have E is going to be multiplied by this next block as GC, which is going to be multiplied by GA and then by GM and then by GP. And it will turn into the output. So essentially, E is going to be multiplied by GC in the forward path, GA, GM, and GP. That results in C. Now we can replace E with whatever that we have calculated over here. So we can write SP minus CH. This final equation that we have is composed of H as one of the building blocks, C as the output, SP is the input, and is going to be multiplied by all of those G multiplications. So I would like to call it like GT, for instance, in order to just simplify our rating, GT. So essentially, multiplication of GT, which we know all of the ingredients of it, times the input minus C as the output times H as the building block becomes again the output. So we know all of the individual building blocks of this case. Therefore, we can further simplify them so that we can solve for C. And in this case, we can expand the right side, SP times GT minus CH GT. Then C on the left side can be summed up with CHGT on the right side, and that becomes SPGT. Now, if you factor from C, we would have 1 plus HGT, which becomes SP times GT. And now the question is asking, try to find C divided by SP. So if I try to calculate C divided by SP, I see that C is going to be multiplied by 1 plus HGT. So I'm essentially going to copy that and bring it down there. And we know that GT is going to be multiplied by SP. So GT at the top is going to be multiplied. So essentially, this is our final answer. The output over the input with respect to the return path, or H, is going to be as shown. And if you can compare these two results that we have over here for the second part compared to the one that we have for the first part, we see that if H becomes 0, the denominator reduces down to 1, and the whole transfer function becomes then GT, which essentially is the same as here. So this multiplication of all the building blocks in the forward path is GT. So those results match with each other in case of open loop system. Let's move on to the third part of the question. It's saying closed loop transfer function Cm now over Sp. Now that we have the closed loop transfer function of C over Sp, we should find a relationship between now C and the variable of interest in the question Cm. And we see that there is a readily available equation that relates C and Cm using one of those building blocks of H. So we will use that. Instead of writing C, we would place that with Cm over H, which is the parameter that the question is asking. Now, in our question, we will reuse this. We will reuse this here. However, instead of C, we will be replacing C with Cm divided by H. And the question is asking, what is Cm over Sp? So Cm over Sp is right here. We just need to multiply both sides of this equation by H in order to get rid of this H in the denominator. And what is left is going to be Cm over Sp. So if we do that, simply Cm over Sp becomes then GT times H divided by 1 plus GT times H. This is going to be the answer for part 3. So here is part 3. This was part 2 indeed. Now, the final part of the question is derive the transfer function C over D, where D is the disturbance input. So this now will become a completely different question. I'll be copying this and try to solve this question. So essentially, when we are asked about a different input, in this case D, we need to assume that there won't be any other input. In this case, SP is going to be 0. So if you assume SP to be 0, still considering the closed loop scenario, we need to consider again what is coming from the output towards through this feedback. So essentially, again, this node at the output is C, and whatever exists at node is also C. So the input of H is C, and the output is going to be C times H, which we call it Cm. Now, CH is going to, in this case, be fed to this error detector, but this error detector is going to subtract 0 and CH. In this case, error detector is going to be 0 minus CH, which simply is going to be minus CH. Now, this error is going to be multiplied by all of these factors before getting to this node with, let's call this node as X, for instance, the node right before D. So X then becomes multiplication of the input, E, times GC, GA, and GM. Essentially, the output over here is multiplication of all of these building blocks by the input to that. And we know that E is simply minus CH because we just found that. So let's replace that, GC, GA, GM. Now, we know that there is a building block called GP that essentially has two inputs. There is one D, there is one X. And essentially, these two inputs are going to be summed up and then multiplied by GP, which will result C as the output. In a sense, in this case, D is going to be summed up with X and multiplied by GP. This results in C. Whatever that it enters a building block is going to be summed up with each other and then multiplied by that building block. It is very similar to the summation box. Now that we know what is X, we can just simplify this as GP times D plus X is going to be replaced by this value here. And since we are dealing with negative number, we won't use plus. So essentially, you can see that in this final equation, now we have the relationship between C as the output and D. All of the other parameters in terms of GP, H, GC, GA, GM are all known. There's also a secondary C here that we need to take it out and bring it to the other side of the equation, and let's do that. So I'll just expand this GPD and minus C times H times GP, GC, GA, and GM. So if you solve for C, we would have C times C plus CH, GP, GA, GC first, GA, and GM. They all become equal to GP times D. Now we can factor out from C, which would take us to 1 plus H, GP, GC, GA, and GM. Now that we have all of this information, we can easily find the relationship between C and D. and I'm going to actually write it here. C over D essentially is going to be, so D is going to be multiplied by GP. So I'm going to write it at the top. And C is going to be multiplied by this whole phrase here at the bottom. And I'm going to actually bring it up there. So essentially C is going to be multiplied by this whole term, which is here. And D is going to be multiplied by GP, which is here. So essentially C over D is going to be as follows. So let's move on to the next question. Question number 2 is essentially saying, try to find the transfer function of C over R. And in this case, we know that this is simply a cascade of simpler closed loop followed by a gain of G2. So we can break it down into smaller pieces of first try to find the transfer function of the first part and then multiply whatever we get by G2. Now, in order to find the first one, we can call this intermediate node as X for the time being. And regardless of what comes after X, we'll start actually from this node down there to follow the return and feedback path. We know that when there is a node called X, whatever comes out of that is also X. So X to the right, X to the bottom. Now X is going to feed H1 and the output would be X times H1. Now moving up, H1 is going, XH1 is going to be multiplied by negative sign and it's going to be summed up with R times positive sign. So essentially this output of the error kind of detector that is that we call it as E is essentially R times plus sign plus minus sign times xh1, and simply it becomes R minus xh1. Now we know that E in this forward path needs to be multiplied by G1 to result X. So E times G1 becomes X. Now let's simplify E as we just found it up as R minus xh1. This equation actually tells us it needs to be multiplied by G1 essentially. We need to then work on this equation to solve for X. So essentially, if we simplify that, we have X equals R G1 minus X H1 G1. Now, X equals, we can move the second term to the right side, X plus X H1 G1 equals R G1. And if we factor out X, it would be 1 plus H1 G1 equals R G1. And if I find X over R, I would get R times G1 and X times 1 plus G1 H1. Now we have got actually X over R, which is simply the forward path divided by 1 plus G1 H1, or 1 plus the forward path times the feedback path. So we will remember that for the next questions in general. Now we only have the X over R. We need to further multiply that by G2 to get C, because essentially C is X times G2. So if I simplify this and write X equals C over G2, I can then write it as C divided by G2 to replace X, and I have R here as well. So essentially C over G2 is going to replace X, and in the numerator, R is going to be staying the same. Now, the whole question is asking, find C over R. And in this case, it's going to be multiplication of, in this case, C is going to be multiplied by this. So it will be 1 plus G1 H1. And R is going to be multiplied by both G2 and G1. So G1, G2 are going to be multiplied by R. This result is going to be the final answer of this question. So essentially it is the transfer function of the first part, which is the closed loop, multiplied by the second block, which is G2. In this case, G1 over 1 plus G1 H2 is H1 indeed, is the transfer function of this closed loop, and this is going to be multiplied by G2. Let's move on to the next question. So again, this question is saying, try to find the transfer function of this system. As we recall from the previous part, we need to know that what are the forward path and the return path transfer functions, and then use that in our equation that we just learned. However, in this case, in the return path, we have more than one block. We have H1 as well as H2. Since simply they are cascading each other, we can easily simplify them by just multiplying them together and calling a greater block of H1, H2, which simply is multiplication of H1 and H2, and essentially simplify this whole circuit as shown there. Now, C over R becomes the forward path of G1 divided by 1 plus the forward path G1 times the feedback, which in this case is H1, H2. This simply is the transfer function of this system. Let's try to find the next question's transfer function. In this case, the question is a little bit more involved, and it's no longer a cascade of one or two building blocks or a parallelism of them as well. It's a nested closed loop within another closed loop system. Essentially, this makes it a little bit more involved. However, we will need to label some of the intermediate nodes to be able to solve this question. I would again start from the output of this system, as C is going to feed H2. So C is the output node. I would call it C, that whatever comes out of that is also C. So C enters H2. The output is going to be CH2. Now CH2 is going to be feeding to this error detector. And the output of that, which I can call it as E1, is going to be simply E1 is going to be R minus CH2. Now, this error, E1, is going to be subtracted by some other element that we don't know actually what that is, because that is the product of H1, but it's by its input that we don't know actually that input neither. So we need to know actually this node. However, we know that this node is only one block away from this output, which means that whatever that this node was going to be multiplied by G2 to get C. Is that correct? Which means that there is this node that I can call it as X, and X times G2 is C. This means that X is simply C over G2. So essentially, it's C over G2. Now I know this node, which feeds H1. Then the output of H1 becomes H1 times the input of it, which is C over G2. Now this is going to be then subtracted from each E1 to create the second error, which in this case I would call it E2. So E2 now becomes E1 minus the input of that, which is H1CG2. So E2 is going to be E1 minus its input. Now I can further simplify this, replacing E1 with this one, because we want the intermediate nodes. So R2, so E1 is R minus CH2 and minus the rest of the equation, which is H1C divided by G2. So now we have E2 over here, and E2 is then multiplied by G1 to result X. So E2 times G1 to become x. However, we already knew that x is related to the output as follows. X is C over G2. So I'm going to actually simplify that right away. C over G2. Now I know that E2 is represented with respect to the output. Let's simplify that here as well. I have two equations for E2. One is here, and the second one is here. So from the second equation, I can find E2 to be C divided by G1 and G2. And then I can equate this with this equation. Simply, I can see that it's C over G1, G2. Now I've got actually a final equation that I have all the ingredients that I want. There is output as C, which I like. There's an input or R that I need that as well. And there are intermediate building blocks of C, of H2, H1, G2, G1 as well. So now is the time to simplify this with respect to C. So if I factor out C from the right side, I have 1 over G1, G2, and I can move then these two terms to the right side of the equation. And in that case, I would get plus H2 plus C plus H1 divided by G2. So this whole scenario, when we simplify C of three ingredients of C are going to be summed up with each other on the right side of the equation. The left side equals R. So this whole thing equals R. And in this case, we can have the relationship between C over R as simply shown here. So C is going to be multiplied by 1 over G1, G2 plus H2 plus H1 divided by G2. Here is the final result that we're looking for. And the final example over here that I'm only showing that for your own purpose and practice at home. Feel free to solve this, and if there is any question or concern, please leave a comment below and I'll be answering your questions. Thank you for your attention, and hit like and subscribe to the channel so that you can be notified of the future videos soon. See you soon.